Hello viewers, welcome back to our YouTube channel 3D Parametric Solid Model Drawings. Today we will create sketching of shock absorber assembly in Siemens NX 10 software, which is taken from our suspension assembly. It will demonstrate how to design its component and afterwards how to build the assembly by using the assembly constraints. We have used 13 part files and 4 subassemblies to make this assembly. These pics are showing you to observe it. Okay, let's start. So first we will create this part. Create a new inch part file from here. Set the name of this file shock spring adjustment nut. And click OK. Now we will activate the sketch tool from here. And select the XZ plane to start the sketch. Right click and choose Orient View to Sketch option so that the rotate the part according to this plane. Now we will create a circle from the origin point and its diameter will keep 0.525 inches. Okay, finish the sketch. So let me choose an isometric view. Activate the extrude command and select the circle. Set the distance value 0.075 inches and click OK to create extrude feature. Okay, now see here my first extrude feature has been created in the design window. Now we will select the circle and hide the visibility from here. Okay, save the part. So let me choose create a sketch command. Okay. Now select the front face of this feature. Okay, alright. Now we will activate the polygon tool from here and start the polygon from the center point. Now select this line of the polygon and apply the vertical constraint on over it. Activate the rapid dimension tool from here. Select this point and this point. Okay. And apply the dimension 0.625 inches between these 2 points. Okay, now see here my sketch is fully constrained. So we will exit from the sketching mode. Okay, now we will extrude this sketch 0.125 inches. Okay, alright. Now we will select the unite option under the Boolean area. Click OK. Now see. Rotate the part minus 90 degrees according to Z axis of the part. Now activate the extrude command. Now we will select the infer curves option under the curve rule area. Okay. And select this plane to start the new sketch. Now we draw a circle from the center point. Its diameter will keep 0.5 inches. Okay. Finish the sketch. Now we will select the reverse direction button under the specify vector area and choose subtract option under the Boolean area and choose through all option and click OK. Now see here my hole is cut over through all the body. Now we will activate the edge blend tool from here. Okay. And set the radius of this edge blend. It will keep 0.05 inches. and select all the edges of the polygonal feature like this. And click OK. Now see here, my part is looking perfect. Okay, now we will fix the radius 0.015 inches. Okay, now we will apply another fillet over the front and back edge of the feature. Okay, that's it. Now we will apply another edge blend feature over these two edges of the hole like this. The radius will keep 0.005 inches. Okay, alright. So now my part is completed on here. So now we will go for creating the next part. Here we create a suspension spring. Okay. Now we will activate the new button on here. It will keep as an inch file. Okay, alright. Now we will set the location of the bar file so that our file gets saved here. Now we will create a new folder. Okay, save the bar file with the name suspension spring. And click OK. Activate the PMI button on here. And change the decimal value up to 4 places. Set the decimal delimiter value period and click OK. Now we will activate the sketch preferences option on here. Deactivate the change view orientation option. Okay, that's it. Let's start the sketch tool on here. Now select YZ plane to start the sketch over this plane. Okay, alright. Now select the snap to view option from the design window so that the model rotate along this plane. Now we will create a horizontal line on here and its length will keep 1 inches. Now select the midpoint of this line and sketch origin and apply the coincident constraint between them. Now choose the fit to view. Okay. Now my line is fully constrained on here. Now draw two circles in the design window like this. Activate the rapid dimension tool on here. And select this circle. Okay. Fix the diameter of this circle 0.043 inches. Now select these two circles and apply the equal radius constraint between them. And fix the horizontal constraint on the center point of the circles. Now we will create 2 points over the circle like this. Select this point and the center point of the circle and apply the vertical constraint between them. Select this point and the center point of the circle and apply horizontal constraint between them. Okay, that's it. Fix the tangent constraint between these two circles like this. Now we will select the end point of the line and this point, okay, and fix the dimension 0.275 inches. We will fix the vertical constraint between this point and the end point of the line. Hide the visibility of the sketch constraints on here. Convert this circle and line into reference geometry. Okay, finish the sketch. Now we will choose an isometric view. Okay. Now go to the curve tab. We will activate the helix tool. Now we will rotate the helix minus 90 degrees on here. Drag the helix in this direction by selecting the pointer. Okay. Set the y coordinate value minus 0.4785 inches. Okay, that's it. In the helix dialog box, we will select the turns option under the length method section. Okay, alright. In the size area, we will fix the helix diameter value 0.593 inches. Set the helix pitch value 0.2 inches. And fix the helix turns value 5. Okay. Set the turns direction left hand. Fix the angle value 90 degrees under the orientation area. Now you can see in the design window. And click OK to finish the command. Now see the result. My helix is created on here. Now we will activate the swept command. Okay. First of all, we will select the circle, okay, which will keep as a profile. And then next select the helix on here, which will keep as a guide. Now see the swept preview is visible here in the design window. If you want to create complex features, you can select maximum 3 guide curves on here and click OK to finish the command. The swept feature has been successfully created on here. Okay, save the par file. Now we will change the par color on here. Okay, that's it. Now we will activate the true shading button on here. Deactivate the planar shadow and flow reflection button. Okay, now my spring is looking perfect. Rotate the model in this position. Now we will activate the helix tool once again. Rotate the helix in this position. And drag the helix in this direction. Set the y coordinate value minus 0.4785 inches. Helix pitch value will keep 0.044 inches. Helix turns will keep 2. Fix the angle value to 70 degrees. Okay, that's it. Now we'll create one more swept feature by selecting the helix like this. Go to the selection filter here and select the solid bodies option. You can see here two separate solid bodies are visible here in the design window. We will add these two solid bodies with the help of unite command. Okay, activate the unite command and select the first sweep feature which will keep as a target body, and then next we will select the second sweep feature which will keep as a tool body. Okay, that's it. Now see the result. Now we will activate the intersection curve command from here. At first select the YZ plane, okay, and then next select the entire body and click OK. Now see projected curves are visible here. Let's start a new sketch on the YZ plane. Now we will activate the edit section view command by selecting this plane. Click OK. Take the project of these two curves by activating the project curve command. Hide the visibility of the intersection curve from here. Okay, alright, now we will convert these two projected curves into reference geometry. Now we create a rectangle on here. Okay, select the midpoint of the rectangle line and sketch origin and apply the horizontal alignment constraint between them. Now we will select this rectangle line and this curve, okay, and fix the tangent constraint between them. Okay, finish the sketch. Now deactivate the section view from here. Choose an isometric view. Now we will activate the extrude command from here, okay. And select the rectangle. Now we will choose the symmetric value option under the limits section, okay. Make sure subtract option should be activated under the Boolean section and click OK. Now see the result. My bottom surface of the spring model is plain on here, so we will place the spring easily on my suspension assembly. Close the visibility of this sketch and helix curve, okay. It looks great. Save the file. In the same manner, we will create one more helix over the opposite side of the spring that we had done just before. Drag the helix in upward direction and fix the y-coordinate value 0.5215 inches. Set the angle value 90 degrees and click OK. Create a new sketch on this face and take the project of this circular edge. OK, finish the sketch. Now we will activate the set command and select the circle which will keep as a section. Next, select the helix which will keep as a guide and click OK. Now see the result. Now we will convert two solid bodies into a single solid body by using unite command. Okay, that's it. In the same manner, we will plane the top surface of the spring by using the extrude command that we had done on the bottom surface. Okay, now my suspension spring part is completed. So now we will go for creating the next part. Set the name of this part shock body 1.3 length. And click OK. Let's activate the sketch tool. And now select the XZ plane to start the sketch. Okay, alright. Create a circle from the part origin. Its diameter will keep 0.5 inches. Okay, finish the sketch. Now we extrude this circle 1 inch from this plane. Now see. Activate the shell tool. At first, we will select the front face of the model and set the thickness value 0.035 inches. Click OK. Now rotate the model in opposite direction and apply the edge blend feature on this edge. Okay. The bend radius will keep 0.05 inches. Okay, that's it. Now you can start the sketching directly by using the extrude command on this face in the following way. Now draw a circle and the circle diameter will keep 0.375 inches. Okay, finish the sketch. Now fix the extrude distance value 0.4 inches and choose the unite option and click OK. Now we will start the sketch on the front face. Activate the project curve command from here. Take the project of this outer circular edge. Okay, finish the sketch. Draw a rectangle over this circle. Select this line and the center part origin and choose the point on curve constraint. The width of the rectangle will keep 0.15 inches. Now we will convert these two lines into reference geometry. Okay, finish the sketch. Let's start the extrude command and choose the region boundary curves option under the curves rule section. Now we will select these two sketch profiles on here like this. Choose the reverse direction button and select the subtract option under the Boolean area. End condition will keep until extended. Now we will select this face of the part and click OK. Now see here, my slot is created on this part. Create a new sketch on this face. Draw a circle on here and take the project of this vertical edge. Now we will fix the point on curve constraint between the center of the circle and sketch horizontal axis. Set the diameter of the circle 0.24 inches. Now we will select the circle center point and the side edge and apply the dimension 0.1875 inches. Okay, finish the sketch. Create a hole by selecting this circle. Okay, now see the result. We will fix the chamfer on the hole edge. The chamfer distance value will keep 0.015 inches. Next, we will give the thread on the cylindrical face of this part. Okay, go to the menu, okay, and then next to the insert tab and the design feature, okay, and activate the thread command. Now see the thread dialog box is visible in front of you. Okay, alright. At first, we will select this cylindrical face to where you want to apply the thread. Okay, and afterwards we will select the front face of the model where from cutting the thread would start. Okay, now we have chosen the symbolic thread option on here. Go to the thread table detailed list from here. And select the 1/2-20 UNF size. Click OK. Thread length will keep 0.75 inches. And click OK to create the thread feature. Now we will apply another thread feature on the inner hole face of the part. Choose the 7/16-28 UNEF size. Okay. And set the thread length 0.375 inches. And click OK. Now my shock body part is completed. So now we will go for creating the next part. Set the name of this part shock cartridge. Okay, let's activate the sketch tool. And now select the YZ plane to start the sketch. Okay, alright. Create a circle from the part origin. Its diameter will keep 0.5 inches. Okay, finish the sketch. Now activate the extrude command and select the circle. Fix the extrude distance value 0.125 inches. And click OK. Now see the first extrude feature is created in the design window. Rotate the model 90 degrees from here. Okay. Now we will create a new sketch on the front face. And draw a polygon from the center part origin. Fix the vertical constraint on this polygonal line. Take the project of this outer circular edge and convert this curve into reference geometry. Select this endpoint and outer projected curve and apply the point on curve constraint between them. Draw a 3-point rectangle over the polygonal line. And fix the tangent constraint between this line and the outer curve. Now we will convert the entire polygonal lines into reference geometry. Okay, finish the sketch. Activate the extrude command and select the rectangle. Now we will choose the reverse direction button and select the subtract option under the Boolean area. Fix the extrude distance value 0.125 minus 0.015 inches. And click OK. Now see here, one portion has been removed of this part. Okay, that's it. Save the file. Activate the pattern feature command from here. At first we will select this extrude cut feature. Okay, then next select the circular option under the layout section. Okay, now choose the specify vector button from here and select the x-axis of the part from the design window. Now you can see here rectangular pattern preview is visible in the design window. Now we will select the count and span option under the spacing area and fix the count value 6. Okay, set the span angle value 360 degrees and click OK to create a pattern feature. Now see, it is looking perfect. Now we will give the fillets on the edges of the part like this. Activate the extrude command and select this face to start the new sketch. Draw a circle on here. And its diameter will keep 0.43 inches. Finish the sketch and fix the distance value 0.25 inches. Click OK. Now we will create a hole on this face by using extrude command. draw a new sketch on XZ plane. Okay, and choose the front view. Activate the intersection curve command and select the entire face of the model. Now we will draw the lines on here something like this. This line dimension will keep 0.05 inches. And 0.025 inches. Okay, now select this endpoint and x-axis. Okay, and fix the dimension 0.1875 inches. Okay, finish the sketch. Now we will activate the revolve command from here. And select the entire sketch. Choose the specify vector option and select the x-axis of the part. Make sure the Boolean operation will keep subtract, otherwise the sketch will not be able to cut. Click OK. Now see the result. Okay, now we will create a new plane over this curve like this. Activate the thread tool. Okay, now we will apply the same method over this part for creating the thread that we had done on my previous part. Now my part is completed on here, so now we will proceed with the next part. This file name is piston. Okay, all right. So let's start the sketching on the XZ plane. Now draw two circles on here and apply the dimensions on these circles to fix it. Okay, finish the sketch. Now we will extrude this sketch region 3 by 32 inches. Okay. Apply the edge blend feature on these edges of the extrude feature. Create a new sketch on the front face of the model. Draw a circle and its diameter will keep 0.043 inches. Apply the point on curve constraint between these 2 points. Give another dimension on here, it will keep 0.15 inches. Okay, finish the sketch. Now we will create a hole by selecting this circle. And create 3 copies of this hole by using the circular pattern tool. The part is finished here. Okay, now we will create another part file. Its name is eClip. Okay, that's it. Now we'll start the sketch on the exit plane. Create 2 circles on here. And apply the dimensions on the circles to fix it. Okay, finish the sketch. Activate the extrude command and select the sketch. Fix the extrude distance value 0.015 by 2 inches. Click OK. Start the sketch over the front face. Now we will draw a horizontal line on here. Its length will keep 0.05 inches. Okay, alright. Now we draw two slanted lines on both endpoints of the baseline. And fix the angular dimension 25 degrees between these two lines. Now go to the More option and activate the Make Symmetric Constraint command from here. At first we will select these two slanted lines and next select the center y-axis. Okay, now see. Create one more horizontal line over the top endpoints of the line to connect the sketch. Now drag the sketch from the endpoint. Okay. And apply the tangent constraint between this line and the outer edge. Fix the dimension on this line, it will keep 0.1 inches. Okay, finish the sketch. We will activate the extrude command and select the sketch profile. Now choose the reverse direction button and select the subtract option. We will select the through all option in the start and end area. And click OK. Now see. Create a new sketch on the front face. And take the project of the outer edge. Now we will activate the offset curve command from here and fix the offset distance value 0.03 inches. Take the offset of the outer projected curve inside. Okay, that's it. Now we will draw two more aligned lines on here and apply the symmetric constraint on these lines. Activate the extend tool and extend the lines on this curve. Okay. And trim the extra curve like this. Set the dimension 0.083 inches between these 2 points. Fix the angular dimension 50 degrees between these two aligned lines. Okay. In the same manner, we will create the sketch on the opposite side for creating the slot. Okay, now my sketching is complete, so we will exit from the sketching mode. Activate the extrude command and select the two sketch regions. Okay. Choose the reverse direction button. The end condition will keep through all and click OK. Now we will apply the edge blend feature on all the corner edges of the E-clip model. The radius will keep 0.015 inches. Now my part is looking perfect. The file is complete here. So we will go on to the next part. This part name is ball end. Okay, alright. So let's start the sketch on the XZ plane. Now draw a circle on the center point. Its diameter will keep 0.4 inches. Okay, finish the sketch. Extrude this circle 0.115 by 2 inches from the center plane. And save the par file. Let's start the new sketch on the XZ plane. Take the project of the entire model by using the intersection curve command. Now we will choose the front view. Okay. Create a horizontal line on here and apply the horizontal constraint over this line. Select this line and x-axis, okay, and fix the collinear constraint on over it. Now we will draw two more lines on here like this and create an arc on both the endpoints to connect the sketch. Fix the tangent constraint between this arc and line, okay. Now we will apply the point on curve constraint over these 2 points. This line dimension will keep 0.1125 inches. Point 225 inches, okay. Now my sketch is fully constrained on here, so we will exit from the sketching mode. Activate the revolve command and select the sketch. Now choose the specify vector option and select this horizontal line and click OK to create revolve feature. Now we will start the sketch over the XZ plane and take the project of the entire model. Now we will create two lines on here, something like this, and apply the midpoint constraint between this vertical line and center point of the curve. Apply the dimension 0.1375 inches over this line, okay. Fix another dimension on here, it will keep 0.3961 inches. Now we will create a mirror of this line on the opposite side. Okay. and apply the dimension 0.3154 inches between these 2 points. Okay, finish the sketch. Okay, now we will extrude this sketch 0.115 by 2 inches on both sides from this plane. Okay, that's it. Now we will convert all the solid bodies into a single solid body by using the unite command. Apply the edge blend feature on the 4 corner edges of the model. Okay, that's it. Now we will activate the divide face command from here. At first we will select this outer face of the part. It will keep as a dividing face. Okay, alright. And then next we will choose the XZ plane of the part so that the part will be split in 2 pieces along this plane. Click OK to execute the command. Okay, now see here my part is successfully split into 2 pieces. That's it. Now we will activate the draft command from here. Okay. Under the draft direction area, choose the specify vector option. Now let me choose the first front face of the model. Okay. Under the draft method area, let me choose the parting face option instead of stationary face. Now you can read the detailed information about this option, that how it works. Okay, that's it. Now we will select this dividing edge. Now we will select this dividing edge. It will keep as a stationary parting face. Okay. Under the faces to draft area, let me choose this face. Okay. Now we will fix the angle value 5 degrees. And click the apply button. Okay, now see the result. In the same manner, we will create another draft over the second piece. Okay. Now we will activate the hole command. Choose the threaded hole option. Now we will select the center point of this outer curve to specify the hole location. Okay, now we will select the hash 4-40 size from the list. Thread depth will keep full. The hole depth value will keep 0.225 inches. Start and end chamfer of the hole will not be made. And click OK. Now you can see here my hole is created over this part. Okay, alright, it looks great. Apply some more edge blend features on this part like this. Okay, activate the chamfer command from here. The chamfer distance value will keep 0.015 inches. Apply the chamfer over the whole edge. Okay, alright. Start the new sketch on this face. We will draw a horizontal line on here. Fix the collinear constraint between this line and the x-axis. Now draw an arc on this line. And its radius will keep 0.125 inches. This line dimension will keep 0.25 inches. Okay, finish the sketch. Now we will create a hole by selecting the sketch with the help of Revolve tool. Okay, now see. And apply the chamfer on the front and back hole edge. Okay, now my file is completed on here. So we will go on the next part. This part name is Spring Cup. Okay, alright. So let's start the sketching on the XZ plane. Draw the three lines in the graphics area something like this. Okay, now we will select the x-axis and this horizontal line, okay, and apply the collinear constraint over it. And apply the dimensions on these lines to fix them. Now we will draw the lines from this endpoint. Fix the dimension 0.2 to 5 inches. Okay. Point 0.05 inches. Okay. Okay, we will draw some more lines in the following way to connect the sketch. Select the z-axis and this endpoint of the line and fix the dimension 0.338 inches. Now we will give the equal constraint on these two lines. Okay, and apply the collinear constraint between these two lines. Now we will adjust the sketch lines by dragging the endpoint. Okay, and apply the collinear constraint between these two lines. Now my sketch is complete, so finish the sketch. Activate the revolve command and select the sketch. Select the z-axis to locate the revolving axis and click OK. Now see, my first revolve feature has been created in the design window. It looks great. Apply the edge blend feature over this part. Okay. Now we will create a new sketch on this face. Choose the orient view to sketch option from the design window so that the model is to be rotated in this position. Okay, alright. Activate the project curve command and take the project of the outer edge of the model. Now we will draw a vertical line and apply the collinear constraint on this line and y-axis. Fix the midpoint constraint on the mid of the line and sketch origin. And its line dimension will keep 0.063 inches. Now create two aligned lines from both the endpoints of the center vertical line like this. Okay. And activate the symmetric constraint tool from here. At first we will select these two lines. Okay. And then next we will select the x-axis. Okay. Now see. We will fix the angular dimension 10 degrees between these two lines. Okay. Now we will trim these lines from here which are outside of the part. Okay, alright, finish the sketch. Activate the extrude command and select the sketch. Now choose the symmetric value and subtract options in the dialog box. And click OK. Now see here, my slot is cut on the model. We will apply the edge blend feature on the entire edges of the part. Okay, now my part is looking perfect. The part is completed on here, so now we will go for creating the next part. Set the name of this part 0.25 ball. And click OK. Start the sketch on the exit plane. Now draw the two circles from the part origin. One diameter is 0.25 inches and the other is 0.125 inches. Draw a vertical line on here and fix the line on the x-axis by using the collinear constraint. Trim the line up to this circle. Okay, finish the sketch. Now we will revolve this sketch profile like this. Okay. Now we will create a hole by selecting the internal circle with the help of extrude command. Okay, that's it, and close the part. Okay, let's start the new part file. This file name shock shaft. Now we will start the sketch on the exit plane. Create a circle from the part origin. The diameter will keep 0.125 inches. Finish the sketch. Now we will activate the extrude command and extrude this circle 1.25 by 2 inches on the both sides from the center plane. And hide the visibility of the previous sketch. Okay. Save the part. Now we will activate the extrude command and select the front face of the model to start the new sketch. Now draw a circle from the center point. The circle diameter will keep 0.112 inches. Okay, finish the sketch. Fix the extrude distance value 0.2 to 5 inches. Okay, choose unite option and click OK. Okay, now you can see here my second extrude feature has been created over this part. Activate the datum plane command and choose add distance option. Okay, at first we will select the back face of the part. Choose the reverse direction button and enter the offset distance value 0.032 inches and click OK. Now see, my plane is created on here, and start the new sketch on this plane. Activate the project curve command and take the project of front and back circular edge of the model like this. Okay. Finish the sketch. Hide the visibility of this plane. Now choose the static wireframe option from here. Okay. Activate the extrude command once again and choose region boundary curve option under the curve selection list. Select the sketch profile. Okay. Enter the extrude distance value 0.015 inches. Now choose subtract option and click OK. Okay, now we will choose the shaded with edges option. Now see, my slot is cut over this part. Save the par file. Okay. Now we'll activate the datum plane command once again and create a new plane from this face. Okay, and set the offset distance value 3 by 32 inches. And start the sketch on this plane. Okay, now we'll take the project of these two circular edges of the slot. Finish the sketch. Now go back to the static wireframe option and activate the extrude command. Select the sketch profile and click OK. Now see, my second slot is cut over this part. Now we'll activate the chamfer tool from here. Okay, select the front and back circular edge of the part and click OK. Create a new plane on this circular edge. Okay, and activate the thread tool from here. At first we will select this circular face of the model for placing the thread. Okay, and select this plane. It is our starting plane of the thread. Now choose unified option. Now go to the thread list and select the 4-40 UNC size and click OK. Alright, now you can see here symbolic thread feature is created. Now we'll create a new part file from here. Okay, and set the name of the file O-ring. Click OK. Let's start the sketch on XZ plane. Okay, alright. Now we'll draw a circle on here. Okay. Now select the center point of the circle and horizontal axis and apply the point on curve constraint. This dimension will keep 0.094 inches. Okay. The circle diameter 0.063 inches. Finish the sketch. Now choose the revolve command and select the circle. Choose the z-axis to specify the vector. Okay. Now see, a revolve feature is created here. Okay, now my O-ring part has been completed here. So close the part file. So now we will go on the next part. Now we will create another new part file from here. Its name is shock voltage cover. And start the sketch on XZ plane. Okay. Activate the line tool. Start the line from the part origin. Okay. Now create another line on here from this endpoint. Now this line dimension will keep 0.205 inches. Okay. And this line dimension will keep 0.07 inches. Create another line from this endpoint and its length will keep 0.025 inches. Okay, now create 3 more lines like this. Select this line and z-axis and fix the dimension 0.188 inches. Now we will apply another dimension 0.178 inches between this endpoint and center axis. Draw 2 more lines to close the sketch profile. And give the dimension 0.065 inches between these 2 lines. Now this line dimension will keep 0.02 inches. Okay, and fix the dimension 0.025 inches between these 2 lines. Okay, finish the sketch. Now we will revolve the sketch. And give the edge blend feature on the edges of the model like this. Now my part has been completed on here, so now we will close the part file. Create another new part file. This file name is shock voltage spacer. Okay, alright. Create the sketch over the XZ plane. Now we will create a circle from the part origin and its diameter will keep 0.25 inches. Now we will draw another circle on here. Its diameter will keep 0.135 inches. Okay, finish the sketch. Now we will extrude this sketch region 0.165 inches. Okay, that's it. And apply the edge blend feature over the entire edges of the model like this. The radius will keep 0.005 inches. Okay, alright. Now all the components of the shock absorber assembly are finished here. So now we are going to create a new assembly on here, which name is ball end underscore 1. Okay, alright. And place the part ball end in this assembly. Now we have selected absolute origin option on here. Okay. So first we will activate the assembly constraints command and we will choose the fixed constraint on here. Apply this constraint over the ball end part like this. Okay. We will insert the 0.25 ball end part on here. It will keep as a move position. Now we will change the color of this part on here as light gray. Okay, now my part is looking perfect. We will open the visibility of datum coordinate system of this part. Okay, return to the assembly environment. And drag the part by activating the move component command. Now we will fix the center axis constraint between these two holes of the components. Okay. Choose the align constraint option. Select the exit plane of the bar end part and select the exit plane of 0.25 ball part to fix the align constraint. Okay, now see the result. My 0.25 ball part has been properly placed on the center of the ball end assembly. Okay, now assembly has been completed on here. So now we are going on to create another new assembly on here, which name is shock strut. Okay, alright. And place the part shock shaft in this assembly. And apply the fixed constraint on this part. Now we will insert the piston part on here. Okay, alright. We will activate the assembly constraints command and we will choose the center axis constraint on here. Apply this constraint over the outer cylindrical face of the piston and outer cylindrical face of the shock shaft part. Now drag the piston on the back side. Okay. And insert the E-clip part in this assembly. Now we will place the two copies of this part. Okay, drag the E-clip from here and fix the center axis made between the outer cylindrical face of the E-clip and outer cylindrical face of the shock shaft part. Now we will apply the touch constraint between the top face of the E-clip and the back face of the piston. In the same manner, we will fix the second E-clip over the opposite side of the piston like this. Now we will hide the visibility of the constraints by activating the show/hide command. Okay, my shock strut assembly is looking perfect. Now rotate the assembly minus 90 degrees on here. Activate the move component command from here and select the piston part, okay, and drag the part in the back side. Now we will fix the align constraint between the top face of the piston and slot face of the shock shaft part. Okay, that's it. Now we will rotate the assembly. And place the ball end underscore 1 subassembly in this assembly. Now we will apply the touch constraint between the front face of the ball end subassembly and this slot face of the shock shaft part. Now we will select the inner oblique center axis constraint on here and fix this constraint between the two axes of these two components like this. Now we will place the spring cup part on here. Okay. Activate the assembly constraints command. Choose touch option. Okay. Select this whole face. Okay. And select this face and apply the touch constraint between them. Now we'll select this cylindrical face of the shock shaft part and this cylindrical face of the spring cup part and apply another touch constraint between them. Okay, now see the result. Now we will activate the move components command and rotate the spring cup part like this and hide the visibility of the constraint from here. Okay, now we will create another new assembly from here. Its assembly name will keep shock cortege underscore 1. Okay, that's it. Now activate the add components command from here and place the part shock cortege in this assembly. Okay. Now choose absolute origin option and select the entire part option and click OK. Now see. Now choose an isometric view and hide the visibility of datum plane and sketch of this part like this. And now activate the assembly constraints command and apply the fixed constraint over this part. Save the assembly. Now choose add component command and place the part O-ring in this assembly. Okay, choose move option. Okay. Now drag the O-ring from here. Okay. And rotate the part in this position. Okay, alright. Now we will edit the O-ring part and open the visibility of datum coordinate system of this part. Okay, return back to the assembly. And activate the assembly constraints command. Select the touch align constraint from here. Choose center axis option, select this hole. Okay, and select the Z axis of the O-ring and apply the mate constraint. Okay, now see. Now we will open the O-ring part separately from here. Okay, now go to the part navigator button from here and open the visibility of datum coordinate system from here. Okay, alright, now we will create a datum plane at an offset distance value 0.063 by 2 inches away from XY plane. Okay, that's it. Now see, my plane is created on this part. And now we'll activate the mirror feature command from here and select this plane. Okay, choose mirror plane option, select the XY plane. Okay, now see, my two planes are created here over this part. Now we will resize the datum plane from these points. Now see. In the same manner, we will resize the bottom plane on here. Okay, that's it. Now see. Save the file and close it. Now we will return back to the shock voltage assembly. Okay, and open the visibility of O-ring part. Now we will activate the assembly constraints command, select the touch option. Okay, now we will select this plane of the O-ring and select the internal face of the shock voltage part and apply the touch constraint on here. Okay, save the assembly. Now we'll place another part on here in this assembly. Choose the shock voltage spacer part. Okay. Alright. Drag the part like this. Rotate the part in this position and fix the center axis made between these two parts like this. Okay, that's it. Now we'll choose the touch constraint option from here. Okay, now we'll go on the rendering style drop down menu from on here. Okay, and select the static wireframe option on here. Now select this plane of the O-ring. Okay, alright, and now choose shaded with edges option from here and select this face of the shock voltage spacer and apply the constraint on here. Okay, alright. Now we will activate the section view by selecting this plane. Now see, shock voltage spacer has been properly fixed over the shock voltage part. Okay, now deactivate the section view from here. Now we will hide the visibility of coordinate system and datum planes from here. Okay, that's it. My assembly is looking perfect. Now we'll add another part on here. So now we will select the shock voltage cover part and select the O-ring part. Okay, and place the part in this assembly. Now we'll drag the part like this. Okay, now see. Now we will drag the part in this position. Okay. Now we will rotate the O-ring in a straight position. Okay, alright.
fix the center axis constraint between this hole of the shock cartridge part and z-axis of the o-ring. Okay, that's it. Now select this plane and this internal face and fix the touch constraint on here. Select this one and this one, okay, and fix another touch constraint between them. Okay, alright. Now we will apply the touch constraint between these two faces of the components like this. Okay, now my shock cartridge subassembly is looking perfect and it has also been completed on here. So now we are going on to create another subassembly on here, which name is shock body. Okay, alright, and place the part shock body 1.3 length in this assembly. Now we have selected absolute origin option on here, and now we will choose the entire part option. Okay, now see on here and give the fixed constraint over this part. We will insert the shock cartridge _1 subassembly in this assembly. Okay, its position will keep as a move on here. Now we will drag and rotate this component like this. Hide the visibility sketch and datum planes on this assembly to clear the view. Okay. Now we will fix the center axis constraint between these two assemblies like this. Okay. Now we will drag the shock cartridge assembly on here. Select this one, okay, and select this and apply the touch constraint between them. Okay, alright. Okay, now we will select the angle constraint from the list, and now you can see here my 3D angle option is already been activated in the subtype section. Okay, so let's select this face of the shock body 1.3 length part and select this face of the subassembly of shock cartridge cover. Okay, now see my 180 degrees angle is fixed on here, and click OK to apply the angle constraint. Okay, that's it. Now we will hide the visibility of the assembly constraints on here. Okay, alright. Now we will create another new subassembly on here. Now this assembly name as shock absorber and click OK. Alright. Now we will place the part shock spring adjustment nut on here. Okay. Now we will select the absolute origin option. Okay. So that this part is placed over the origin point of the assembly. Okay, alright. Now we will activate the constraint tool and apply the fixed constraint on over this part. Okay, alright. Now we will activate the add components command from here and place the part suspension spring on this assembly. Now select move option on here and click OK. Now we will drag the spring like this. Okay, activate the constraints command from here, choose touch align option. Okay, and select the infer center axis option. Okay, at first we will select the axis of the spring, and then next we will select the whole of this part. Okay, and apply the axis made between them. Now see, now drag the spring in this direction. Okay, by selecting its z-axis. Okay, now we will place the subassembly shock body on here. Okay, that's it. Now drag this subassembly like this. Okay, and rotate the assembly in this position. Okay, alright. Now we will apply the axis made between these two components like this. Okay, that's it. Now drag the assembly in this direction. Okay. Choose zoom all. Click save. Hide the visibility of the sketch and data planes like this. Okay. Now we will choose on here distance constraint. Okay, and select this face. Okay, select this face. Okay, and apply the distance made between them. Fix the distance value 0.4003 inches. Okay, alright. It looks great. Now we will apply the angle mate. Okay. Select this face and select this face and click OK. Okay, now you can see here my 180-degree angle constraint has been applied over this part. Okay, alright. Okay, now we will place the subassembly shock strut in this assembly. Okay, that's it. Now see. Now we will rotate the assembly in this position. And drag the assembly like this. Now we will select the touch align constraint from here. Okay, and select the touch constraint. Okay, now select this face of the spring. Okay, rotate the assembly and select this internal face of the shock strut assembly and apply the touch constraint between them. Okay, now see. It looks great. Now rotate the assembly minus 180 degrees from here. Okay. And now we will activate the assembly constraints command. Select the angle constraint. Okay. Now we will select this face of the assembly and select this face. Okay. And apply 180 degrees angle constraint on over it. Alright.
Okay, save the assembly. Finally, my shock absorber assembly has been completed here in Siemens NX. I hope you will enjoy this video. If you may like this video, please like and subscribe to our YouTube channel. Please share this video with your friends and colleagues. So now I will meet you in our next video. Okay friends, bye bye and have a nice day.